now that we have finished the unit testing, or went through the brief introduction to unit testing in Go, we're going to now look at how to containerize this Go application that we've written, and how can we then run it from a Docker container and then still be able to interact with the GitHub webhook and get the response back from LLM and post it as a comment into the pull request. Now, before I jump onto that, quickly, just to kind of emphasize on why it's important to containerize an application like this. So first of all, at a large scale, right, if you're trying to run these GitHub bots, let's say they need to be run for every repository. And if you've got depending on how many teams you've got in your organization or in your company, right, you would ideally, and I guess it would actually be proportional to the number of repositories you have rather than the number of teams, because one team could have multiple repositories where they would want a bot to come in and make the suggestions or improvements for their code. So things like that, you don't really want to use a single instance of a GitHub bot in those scenarios, right? Because that could be overloaded. As you can have multiple merge requests, multiple pipelines, all running in parallel from various different code bases for one single organization, right? So it could be quite overloading for if you just have one application instance for this GitHub bot application that we are developing. Now, if you run this application in Kubernetes, for example, right, for which one prerequisite is that it needs to be containerized. Now, if you're running it in Kubernetes, you could have multiple instances of this application, right, that could scale based on your load on CPU or load on memory. So utilization of CPU and memory. Based on that, you could dynamically spin up a new instance of this GitHub bot. Or you could go even more fine-tuned and granular, where you could set up like a custom Kubernetes controller that would spin up a GitHub bot for, let's say, a given repository, right? For every repository, you've got a dedicated GitHub bot, which is responsible solely for whatever merge request or whatever pull request is happening in that particular repository. That way you could really scale it up. And all of that, a fundamental piece that you need to do in order to actually get to that kind of scalable state is containerize your application so that it's portable. First of all, you could easily run it in another machine. It's not like there's no dependency on certain packages or dependencies to be installed in your machine first. You still need those dependencies, but that's where you can package it and have this Docker image that you could go and run from the cloud, right? Let's say from a EKS instance or a GKE instance or even an AKS instance in Azure, anywhere, doesn't really matter, any cloud. As long as you've got a Kubernetes system that can run container, you can run the container there. And that's the benefit of it. Now, let's go ahead and actually start creating our Dockerfile in here. So we're going to go ahead. If you're not familiar with the Dockerfile, that's okay. I'm just going to be walking you through it as I do. So first thing we're going to do in the Dockerfile is we're going to say, right, what's the base image? So base image here basically means we're using Golang 1.24. So I'm basically saying that, and these images are available in Docker Hub. So they're open source and free to use. So here I'm basically saying that Dockerfile, in the Dockerfile, I'm giving an instruction. So each line here is an instruction for Docker, and by default it's configured to go and pull the image from Docker Hub, which is where all the open source images are usually stored. And I'm here sending I'm setting up an instruction here to get the 1.24 version of the Go language program, right? That's what I'm doing here. Now, if you were to use Python, you'd simply just use Python instead of Golang. If you're using Node, you'd use Node, and so on. The next thing that I'm going to do is I'm going to set up a thing called work directory, and I'm going to call it app. Now, this doesn't exist in my file structure, But what this does is that this is instructing that after here, so after line 3, whatever happens, it must happen within this directory of /app, right? So for example, I do something like copy, right, and I do go.mod, which is our module file for Go, and let's also go.sum, and we put it into root. So this by default is going to copy go.mod and go.sum file under these within this app directory, right? That's what this is doing here. So I don't actually have to explicitly say something like this. This is already inferred because I've set the work directory to /app. And following on from that, I'm going to now go ahead and do run go mod download. What this does is that it actually goes ahead and runs all the dependencies that we have. So if I open up go.mod, these are all the dependencies that we need in order to run this application successfully. And this instruction does exactly that. So think of it like similar to installing, if you're coming from Python, a requirements.txt file, right? If you're working with Node, it's the package.json file. So it's all your dependencies that you want to run before you copy any source code, because your dependencies are not going to change as much as your source code. So you're going to get, so basically you want to be able to preserve or reuse those layers of within your Docker image, so that the build is much faster. I can make another video if there is interest from the community to go into a bit more detail about how the Docker images are designed, how these different layers of images work, and why it's important and a good idea to install your dependencies before you actually set up an instruction within your Dockerfile that's copying the code over into the image. So let's now just go ahead and copy everything. So here we're saying copy everything from the current directory into the work directory of /app. And then we're just going to go and run our build command. So what this does is just go build GitHub, let's call it GitHub bot, current directory. So here what go build does is that it takes all the code in here and it creates a binary. You give the binary a name. The -o flag is basically asking what's the name of the binary, where is it going to be stored, and where is this binary going to be stored. So we want to store this binary in the root directory here, or the working directory in the Dockerfile, which is /app. And then we're also going to expose a port, because we know that we need to expose the port. So let's do expose 8080. That's our port, that's our port. And lastly, we're just going to run the command, and we're going to pass the executable in, which is the binary. So in our case, this is in code GitHub bot. So this in our case is the actual binary that we're working with. Why is that flagged up? Not sure. Okay, we'll have a look. Sometimes VS Code can play up. Oh, okay, I see why. It's because of the space. Okay, great. So here we're saying that pass the basically use the binary and run the binary. And this binary is essentially all this code that we have got in here, the application. A go build process always results in that binary. So if you now go ahead and we actually build our image, so let's do Docker to build the image. The command is docker build. You give it a tag. So in our case, we're just going to call it GitHub bot, and let's say it's v1. Then we put the build context, which is the current directory, as this is where the Dockerfile actually exists, right? So just give the image tag and where the Dockerfile exists, the path to that basically. And it will take some time. But once it's up and running, we're going to run a container with this image that we are building. And we're also going to be passing in the port, bind it to the port 8080 on my machine here. And I'm also going to be mounting a volume containing the credentials for AWS so that we can access AWS Bedrock. we don't really want to hard code the credentials inside a Dockerfile. It's actually an important thing to remember if you're working commercially. In any production environment, you would never want to hard code your secrets or your credentials in your Dockerfile, because Dockerfile most likely is going to be going and it's going to live in some sort of version control, and you don't really want your credentials to be lying around there. So best practice, always pass it through either mount it, pass it as some sort of end variable. We'll look at a bit more in detail when we are actually trying to use Kubernetes for it. Because in Kubernetes applications, the best practice is always to use things called Kubernetes secrets. Docker has got this Docker secrets as well, but that's for another day, and I'm probably will make another series to go through that. But here you go, our image is done. Although there is one thing that we have missed in here, which will be necessary in our case. Well, actually, we're copying everything, so the .env should be there, so don't worry about it. We'll actually go back and try to run our container now. So we'll do docker container run, give it a name so that we can easily exec into it or remove it if we're done with it. It's always a good idea to give some sort of identifier. Usually you would use a thing called Docker Compose if you're running multiple Docker services locally. For build, for test, for running as mocks and things like that. But in our case, since it's just one application, it doesn't really matter too much. But this is how I'm here. I'm with the -p flag. I'm saying bind the port to 8080. And lastly, I'm going to pass in the volume flag, which is with -v. And here I'm going to mount the volume, mount the directory that I have at my home directory. It's AWS/credentials. So if you're working with AWS and you've used AWS CLI to set up your config, you'll automatically have it. So you'll have it in your home directory too. And yeah, in here we're just going to say AWS. So in the actual container, we want to mount this directory under the root path, as that's where it's always going to expect it. And we are then going to pass a reference to the image that we just built, which is v1. And after that, we're just going to go ahead and hit enter. Now this is going to go ahead and spin up our container, which is listening. It's set up the Go application server, HTTP server, and it's listening for the request coming in. So let's go ahead and actually let's go ahead and delete this comment. This is from our previous run, and we're going to go ahead and close the pull request, and then we're going to reopen it. And if you look at our terminal now, we'll see usual statements coming in. And if we go back now, still need to format the line output. There you go. Even when it's running inside a Docker container, we are successfully able to send the LLM response back as a comment into the GitHub pull request. Right, now let's go ahead and kill our container, and we're also going to do docker container rm-f, and then we're going to pass the name of the container, which we just said github_bot. So that's all gone, and now, so we have written our Dockerfile, which is pretty simple, straightforward. But here's the thing. If I do docker image ls, I see that I've got this container, I've got this Docker image, which is a size of 1 GB. So if you think about it, I've got very less, it's actually a very tiny piece of code base, right? And we don't really have any big files or anything. So it makes you wonder, why is it 1 GB, right? It should be like in MBs at least. Why is it a gigabyte? There's nothing very data intensive in here for the Docker image to be 1 GB. Now here's the thing. By default, if we set up the Dockerfile like this, it does work. You get your image, you run your application as we have just seen, but it has all of your dependencies as well in that image, right? Which you need to actually build that binary. But once the binary has been compiled, then you don't really need your dependencies anymore because it's all packaged in that one binary, really. So ultimately, what you really need is that binary. You don't really need all these dependencies that are getting stored into the Docker image as part of the Go mod download. Then in addition to that, you also don't need the fundamental infrastructure that's behind the Golang, which is coming from the actual base image that we're pulling from Docker Hub. None of that is necessary. All we need is just this binary. So let's go ahead and look at how we can optimize this. So we're going to be now looking at a thing called multi-stage builds. It's a concept in Docker where you use multiple images essentially. So you build your first image, and in that image you have your dependencies, and then you also build your binary. But in the second image, you kind of copy over the binary from the first image, and that way the second image just has the binary, right? And any other like environment files and things like that, it will have those too. But that will result in a much lighter image, and we'll see the difference. For Go, it's really important to do it like that. Also, to be honest, with any programming language, you could do that. Multi-stage builds are great. They really do make the images more lightweight. And yeah, so we'll look at it. So let's go ahead and actually get rid of all of that. We don't really, well, actually, let's leave it. I'm going to show you how to kind of, so we're going to go ahead and do same thing as before. So let's do Golang 1.24, and we should also use Alpine. So Alpine is kind of the most lightweight version of a Docker image that you can have. So we're going to be using the most lightweight version of Go's base image, yeah? And we're going to call this first image as builder, which is pretty common convention. And then we're going to set up the very much the same things. Actually, we can just copy over all of this bit from here. They remain the same. The only thing we're not going to do is now this bits. So let me copy that and paste it in here. So this is what we really want going on in our first Docker image, or the first stage of the build of this Docker image, right? Now in the second build, what we're going to say is that we're going to use another image here, which is just going to be Alpine. So Alpine is just going to be a Docker image that basically is going to be sufficient enough to let this Go binary or this Go executable, so that allow it to run essentially. So Alpine is a very lightweight. It just has just the bare bones, you can say. Everything it needs to spin up this Go binary, it has got it, and nothing more. But that's all we need for our purposes. So we'll use that base image, but we'll copy in from the first image, which is our builder. That's the alias for it. So we'll copy it from the builder into a directory that we are setting up here now. Let's call it GitHub app /GitHub bot. And we're going to be, so we're basically copying it over from /app /GitHub bot to GitHub bot in the new Docker, inside this new Docker image, right? So /app /GitHub bot is literally because we set the work directory as /app there, and we copied during the build step, we outputted it as a binary named GitHub bot. So that's why we're copying it like this. And we're just copying that binary into inside this image and calling it GitHub bot as well. And we're also going to need, so if you remember the token for GitHub, which is in the envar file, we also want to copy that in, which also exists inside the app directory. So let's do this. So we are literally just copying the binary GitHub bot and the env file that we have copied over as part of copying everything. Now this is how you wouldn't do it like this when you're running it in production like in Kubernetes, as I was saying earlier. For that, we'll look at using Kubernetes secrets or just using a config map as well. But I'll be looking at that in the future videos in this series. But for now, we're just copying it over. It's not really a big deal when we're working locally. But essentially, this is the change now. So this is our first layer, or the first stage of the Docker image. And this is the second stage where we're stripping out all these extra stuff that we don't really need. So now let's go ahead and actually kind of build our Docker image. And I'm going to keep the previous one. Let's just go to v2 and let's build it. And once we have built it, I'll just do Docker image list, and we can then compare the size of it, size of this v1 and v2 images, and that will show you I'm sure that will bring about an appreciation on why multi-stage build is so much better and makes sense. Because you got to think about it, right? If the image size is small, that means that when you're running it in the cloud in a distributed system, it's going to be much quicker for a Kubernetes cluster to pull it, for example, right? Because you still need to pull Docker images in order to actually run them. So smaller they're in size, quicker they're to pull, and then quicker they're also to start up, and so on, and less memory and less storage space it takes, right? Because you do have to, after you download it, you do need to store it somewhere. So we'll let this build, and once it's built, we'll look at the size of the image, and then we'll just run the container just to make sure that it's all working well. And let's go ahead and delete this again. And we're going to close the pull request. Let's go back to the terminal. Cool. So let's just now do Docker image. There you go. The v2 has a size of only 20 megabyte compared to a 1 gigabyte, which was with v1. That's a drastic amount of reduction in the size of the Docker image, right? So you can imagine why a lot of the Go applications are following a pattern of multi-stage build, right? But anyways, now let's just go ahead and run the container with the new image and see it's all working well. So same thing as usual, nothing changed here, just changing the pointing it to the new Docker image. And we'll now go back and reopen the pull request. That's going to trigger the webhook, and we're going to be getting, as usual, the log messages coming in from our application. Says the post was successful, and there you go. So there it is. We have successfully containerized our application, and we can still work with it based on some activity going on with the pull request in GitHub. And this is it for this particular video. But in the next video, I'm actually going to be touching on how do we now deploy this into Kubernetes. And since we're talking about platform engineering, I'm also going to be taking some time and introducing and running you guys through Terraform. It's going to be a short crash course on Terraform as we try to set up the Kubernetes cluster and all other infrastructure that are necessary to run this application. On EKS, the Elastic Kubernetes Service in AWS. And then from the Kubernetes service, we will be interacting with AWS Bedrock and the GitHub API. So we're not going to need the ngrok service that I've been using locally anymore, right? And yeah, so the next bit is going to be just focusing on Terraform and how do we spin up a Kubernetes cluster with Terraform and all other, and I'll walk you through like IAM, and I'll also work you through setting up virtual private cloud, subnets in AWS, which are all necessary elements in order to actually have a Kubernetes cluster up and running in EKS. But yeah, all that to come. If you've liked this video so far and this series so far, then stay tuned. There will be more interesting stuff coming in, I promise. And yeah, if you enjoyed the content, then please do like, subscribe, and share with anybody else that you think would benefit from it. That's it. See you in the next video.